Hey everybody, welcome to the last unit of pre-cal. Woohoo, yay! We are going to go through some probability for our last unit and then we'll be done. So I've taken today's lesson and split it up into 3 separate videos so you can kind of do one at a time. And there are 2 different worksheets and an in-class practice worksheet. So there is tons of practice for you guys to do as you have the time to do so. All right, so on this first slide, it shows you just very briefly the calculator instructions. They're going to be the first slide for each of these lessons. And this will be in a Word doc or a PDF posted as well, so you guys can either print it out or kind of look at it as you need it. So the probability in your scientific calculator, you press the PRB button and you have 3 main choices. The first one is permutations, the second option is combinations, and the third option is a factorial. If you're using the graphing calculator, you have a couple of extra steps that you do beforehand. You have to press the math button first, then scroll over to the right to probability, and then you'll come across the same options. So number 2 is a permutation, 3 is a combination, and option 4 is the factorial. So just get used to those depending on which calculator you're using. All right, so we got to go through the basics, some definitions, excuse me, I can't talk today, holy cow, about the general multiplication rules. So we're going to talk about what is probability, independent events, and you know what? There's a huge ginormo typo right here. The third one should be dependent events. That's what happens when you copy paste and you forget to check your work. Holy camole. All right, so probability, that is the chance or the likelihood of an event happening. Chance or likelihood of some event happening. If you have independent events, just very briefly, it means that they stand alone. One of them does not affect the other. So they do not affect the outcome of each other. And just a really easy example of that. So if you're rolling dice, you would have 2 dice. So rolling a 6 on one of them and then rolling a 5 on another. Or if you think about it, if you just had 1 die, if you roll a 6 the first time, it has no effect on what number you're going to roll the second time. Okay, so again, fix my typo that I had here for example 3. So in example 3, we're going to talk about dependent events, and those events affect one another. So the events, outcomes affect one another. So an example of this is like if you think about a deck of cards and you have just a regular standard deck of cards. If I first select a king of anything, it doesn't matter, spades, diamonds, hearts, or whatever, and then I do not replace the card. So I pick one out and I don't put it back in. Then the second thing that I pick could be a king as well, or a queen, or a jack, or any other card that you want. Second, select a queen from the deck. So what happens is that now, because I didn't replace the card, I have taken the total outcomes that can occur and decreased it by 1. So the probability of selecting the next card would become even less frequent. okay? And we have an example to help us go through this. So our first one is rolling a 5 and then rolling a 6 or rolling a 3 on a 6-sided die. So just a regular die that you would spend when you're playing some game. All right, so what's the probability of rolling a 5? Well, you've got 1 5 out of all total. So you're always going to put like what you want over the total. That's how you can get an individual probability. So the probability of rolling a 5 is 1 out of 6 options. And then, anytime it says and, you are going to multiply. This is the multiplication rule. And then rolling a 3. So again, to roll a 3, there's only 1 out of 6 choices. So if I take 1/6 and multiply it by 1/6, we get a likelihood or a probability of 1 out of 36. And I mean, we're not going to go around talking about it like in those manners, so we're going to put it into decimal form, which is 0.0277 repeating. So you have 0.027 as a probability, or a 2.77% chance of rolling a 5 and then rolling a 3. Okay, those two things stand alone. So these are independent events. They do not have an effect on one another. All right, example 2, what's the probability of drawing a king and then a queen from a deck of cards without replacement? Okay, so no, that should say, yeah, without replacement. Got you. All right, so drawing a king. How many kings are there in a deck of cards? Okay, well, first off, we've got to know you have 52 total cards. And you have 13 of each suit. Excuse me. And there are 4 suits. So that means I'm going to have 4 kings, 4 hearts, or excuse me, 4 kings, 4 queens, 4 jacks, 4 tens, all the way down to aces. So the probability of rolling a king would be 4 out of 52. Now, if I do not replace, then the probability of me selecting a queen now comes out of 51 total cards because I have not put that king back into the pile. I still have 4 queens though. And again, it's an and problem. It says choosing this and then something else. So we would then multiply those two probabilities together. So the king is 4 out of 52. The queen is 4 out of 51 because we've reduced one of the cards to choose from. That gives us 16 over, I forget what that number is. Well, here we'll just reduce it. It becomes 4 out of 663. Or 0.006. So that is your probability, or 0.6% of a chance of that occurring. Okay. All right. So in our next one, we have a bag that contains 6 black marbles, 4 blue marbles. All right. So we have a total of 10 marbles. 2 marbles are drawn from a bag without replacement. What's the probability that both are blue? Okay, so the first chance of picking a blue marble is 4 out of 10. That's the first one. But if I am not replacing it without replacement, then picking the second blue marble, I've gone down to only having 9 to choose from total, and 3 blue marbles because I hope that I have chosen a blue one the first time. So that's 4/10 times 3/9, which you could simplify if you want to beforehand, or you can just multiply straight across and reduce to give you 2 out of 15, or a probability of 0.133 repeating, which would be 13.3% chance of the time that that occurs. There you go. All right, so our next little thing to go through is called the fundamental counting principle. And it's basically, you guys did these a long time ago where you would do like a tree diagram and you would draw the little lines out. And I'll show you one of those just real quickly with this example as well. So our first example we have, number 4, is suppose that you have a black and a white pair of pants. Okay. You also have a striped shirt, a polka dotted shirt, and a plain shirt. And we want to know how many total different outfits can you create. So if I were just to draw a tree diagram and figure this out, if I did the white pants, I can wear them with the striped shirt, I can wear them with a polka dot shirt, or I can wear them with a plain shirt. I also have my black pants, I could do the same thing. I could wear it with a striped shirt, the polka dotted shirt, or the plain shirt. So at the tail end, if you count all of the final things that you have at the end of your tree diagram, you see you've got 3 outfits with the white pants and 3 outfits with the blue pants. So you have a total of 6 outfits. So that's one way to do it. An even easier way to do it, because if you're doing just a couple things, it doesn't take any time, but if you've got several different combinations of things that you can put together, you take the total of one item and multiply it by the total of the other item and multiply those together to get 6. So either way, you got 6 outfits with your 2 pair of pants and your 3 shirts. All right, so now we're on to the good stuff. Pizza. Your family has favorite pizza toppings: ham, pepperoni, sausage, onion, peppers, mushrooms, and hamburger. And we want to know how many different pizzas could your family make if they only chose 1 meat and 1 veggie. All right, so how many total toppings do we have? All right, we have ham, pepperoni, sausage, onion, peppers, mushrooms, and hamburger. So we have a total of 7. Now let's differentiate between the meat and the veggie. So for meat, we have ham, pepperoni, sausage, and hamburger. So that means we've got 3 veggies: the onions, the peppers, and the mushrooms, 3 and 4. So if I'm only choosing 1 from each of those, just like we only chose 1 pair of pants and 1 shirt for the last example, I've got 4 choices for a meat and 3 choices for a veggie. So I have a total of 12 different pizzas that we could create if we're only choosing 1 of each topping. All right, our next example, you have to choose 1 of 4 essay questions and 1 of 5 extra credit questions to complete on your biology EOC. How many different ways can you complete the exam? Okay, so we've got 4 essay questions and means to multiply 5 extra credit. So when we multiply those 2 together, you have a total of 20 different ways that you could select an essay and an extra credit question to complete your EOC for biology. And here we go. Our last example of the day. We are talking about the license plates of Canadian vehicles. So you have a letter, a letter, a letter, followed by a number, a number, and a number. How many different license plates can be created? Okay, so how many letters are in the alphabet? And then how many numbers do we have? So there are 26 letters in the alphabet from A to Z. And as far as numbers go, there are 10 because we're going to count from 0 to 9. Okay, so we can do a letter followed by a letter followed by a letter, and then 3 separate numbers. So that is 26 times 26 times 26. You could say 26 to the 3rd times 10 times 10 times 10 times 10 to the 3rd. And when you multiply those 2 values together, you will get 17,576,000 5,000 different ways to create a license plate in Canada. Again, you guys have worksheet A, and then you'll have some other worksheets that you can do as well after this.